Hey Tommy, I've had so much fun with you guys building this wall, chaps, and I mean it's such a beautiful learning experience watching the flow rate and the velocities. And what we discovered today is that 22 mil copper pipe has got the sound velocity of 1,285 meters a second. The galvanized pipe is sitting at 1,438. The random polypropylene, it's actually a very good pipe, even though it's not approved. That stuff takes like 90 degrees centigrade. And then we've got 981 meters a second because it's got aluminium in that pipe, that speed fit. And then that Chinese PEX pipe is sitting at 987 meters a second. But the PVC is 497 and high density polyethylene is running at 435 meters a second. So when you've got a half a liter a minute leak on a high density plastic polyethylene pipe, and you've only got a tiny drip on a copper pipe, because your velocity of your sound of your leak is so much greater on steel, and you've actually got to consider a PEX pipe with aluminium. When you're looking at the resonance, you've got to consider that the speed is so close to metal because there's metal in that composite pipe. So we were looking at the sandblasting and the preparation of it before you epoxy line it. And one thing that you never ever do is try and reline high density polyethylene, because I mean, we know that stuff is oil based. And the mixing process of the diagnostics and getting your flow rate and watching the little ball bearing flow up, and then the gas pressure and the flow rate when it gets to the leak are inversely proportionate. So as the tracer gas gets to the leak, you have a drop in the pressure and a raise in flow velocity. And so this little mixing station is specific. And if you look up there, there's a temperature gauge. So when we introduce hot water into these lines, we have a completely different reaction with temperature. And the leaks increase in size as soon as you throttle down the end here. And this is where all the CFM readers are. So the first part of you understanding pipes is to do your condition assessment and know that when you're running air through a pipe and you look at the exhaust, that you understand, hey, hold on a second, I can't actually use epoxy in here because I might have a mixture of PEX pipe inside your copper, even though your terminal fitting at the wash hand basin. So doing condition assessment, this has been pretty cool. So we've got a bottom leg at the bottom with a hole on the bottom of the pipe. The middle transparent pipe has got a hole on the top. Am I right? The top one had a
hole in the top and the bottom one at the bottom.
The bottom one at the bottom. So when the guys came for training today, they were watching the gas travel, and there's a completely different relationship in the way that the gas interacts and displaces tracer water. In fact, you can actually see a gas bottle still trapped here. And because we don't have chlorine in this water, we've been doing this for 10 years on this property, and we've never had chlorine. The actual pipes turn green. So we have to flush it out, otherwise we lose all these pipes. So this is a low pressure system. And as you can see, it's a low pressure system. Our pressure gauges are sitting at much lower pressures. And then we've got the same mixing station. There's a network of pipes hidden behind that tiled wall. So the guys have to locate all the pipes. We've got some diabolical leaks because, as you know, tracer gas goes vertically, not horizontally, because it's the smallest particle known to mankind. That's quite interesting. We've got a piston meter over there, and we've got an inferential wet dial meter over here, and there's a piston meter. So the guys have got an opportunity to look at the relationship and see, when you're doing wet dial meter or piston meter, which one works and how does it work. The mixing of the fluids and the gases is critical, but the ultimate end game is to rehabilitate these. And you can't rehabilitate unless you actually understand your CFM outlet. So the pipelining guys, when they come for the training, they're going to spend quite a bit of time here understanding the different environments. There's a geyser hot water cylinder over there to produce water, and we'll put a gas installation here as well.